The fourth observation that was made was a quite uninspiring one, but basically, right, if I increase the intensity of my radiation, then it was observed that the current would increase as well, and they were directly proportional. Now, this represented no contradiction to wave theory whatsoever, but we have to understand the quantum explanation for this. And so, let us look at this example over here. So here I have some radiation source, okay, of intensity I. Now remember that I equals to power over area, and we saw that power can be represented as the rate at which photons are emitted by the source, multiplied, of course, by the energy of each photon. And so these photons, of course, will be being emitted at some rate np over t. Okay, they would interact with the metal, and then there would be some rate at which electrons are emitted. Now, what is very, very crucial to understand is that at the metal itself, there is an important quantity known as the quantum yield. Now, the quantum yield is simply the percentage of electrons, or sorry, the percentage of photons that would emit electrons. And so we can write the quantum yield simply as Ne over T as a fraction of Np over T. Right, and this typically that comes to a very small number, about 10 to the minus 6 or 10 to the minus 7. But the point is, right, that there is some linear relationship between the rate at which electrons are emitted and the rate at which photons are incident on the metal. And to wrap this all up, the current that we detect over here, or let's use another I, small I, the current that we detect over here, of course, is the rate at which electrons are incident on the collector plate multiplied by E. And so we can see now there is indeed a linear relationship between intensity and the current.